watching, and basically welcome everybody. My name is James Pick. I am the head of survey and construction here at Copters, and I'm here today to go through a brand new product for you guys. And if you've not already noticed or recognized, this is a new launch called the DJI Zenmuse L3. It's a brand new upgraded system to the Zenmuse L2. And you're probably asking yourself, well, where are these upgrades? What does this mean for my business? Well, I've got lots of information on use cases. I've got lots of information on improved specification for you. And what does that mean for your business? Why is this a product I should be looking at? Maybe you've just started utilizing drones and looking at adding a LiDAR option, or maybe you've used some of the previous LiDAR versions from DJI or other manufacturers, and you're looking to see if this is a potential upgrade for yourself. So worth sticking around for the whole presentation. We have got some exclusive opportunities and then some exclusive deals for people at the end who are looking at upgrading the kit or embedding this kit within their business. So I said, my name is James Pick. I'm the head of survey at Copters, and I'm really excited today to go through with yourselves the Zenmuse L3. So without further ado, let's get into the nitty and gritty of the L3 and what this means for your business. So let's take a step back first. Where did DJI enter this market? So straight away, back in probably 5 years ago, DJI launched the L1. And that was a really good first step for DJI, dipping the toe in the water to come out with a LiDAR system which was available and accessible for businesses to utilize. And then back into 2023, the L2 was launched. And this was, again, a really good step for businesses who probably previously looked at LiDAR. And, from my personal experience, LiDAR was 40, 50, 60,000 pounds. With the L2, this made this a much more available and viable opportunity for businesses to add a LiDAR solution to their kit bag. And the specification was great. We had 5 returns. We had 450 meters range, but in terms of good quality data, was typically flying around the sort of 100 to 120 meters to achieve what we'd say would be good results for survey applications around that 40 to 50 mil. We had no convoluted IMU warms up or calibrations we had to do with LiDAR at the time from other manufacturers. This was a straight, easy to use solution, straight out of the box, plug playing away. And then for processing that data, utilizing DJI Terra, this was a really nice, straightforward SD card out the LiDAR straight into DJI Terra, and a nice, easy to use software package for people to get them kind of results out into a format which is usable, and with the added addition of the PPK processing as well for it. So really good. I was a massive fan of the L2, utilized it a lot over the years from doing demonstrations to businesses, and the results was always good. It was a great LiDAR sensor. So you may be thinking to yourself, well, what possibly more could DJI do for the L3? So I'm going to go through detail with what these upgrades mean and what they actually could be utilized in terms of your business and how that increase your efficiency and data quality from that. So here's the L3. So first of all, you'll notice the biggest improvement straight away is this improvement to returns. So previously we had 5 returns. Now we're up to that 16 returns. That's really great for being able to get through that vegetation, penetrate through that vegetation, and build up that picture from the ground up in terms of detail of what that foliage is, or looking at things like how dense that canopy is. Improved range, put a completely brand new LiDAR sensor on that as well. But for me, the exciting bit is this dual 100 megapixel camera. So you can see from the graphic there, it's on an oblique array at the front, these 2 RGB sensors. Big upgrade from the previous version, the L2, which carried the 1/4 of an inch 20 megapixel sensor, which the Mavic 3 and the Matrice 4 had. So big improvements there. We've added the splatting to the LiDAR processing in DJI Terra, and all them additional functionality you would expect from DJI Terra, plus some new features which I will touch on later on. So on first glance, big improvements. But that's not just all. Not only is it better specification, but also in terms of that workflow with features and included not only on the hardware and the flying itself, but also in that processing with DJI Terra and some additional features coming out for Modify as well. So this is a quick slice of all these additional features. And then we've got now the where that real power is coming from. So we've got that new LiDAR sensor in the head on the L3. Improved IMU, so a brand new IMU in there. This is allowing us to do less calibration in flight like we had to do with the L2. And again, no calibration flights beforehand or after the flight. This is all down to this new IMU. The dual array of the 100 megapixel sensors and the highly integrated manufacturing, as we'd expect with DJI, as we've seen with all them products. This is an all-in-one encompassing unit. One flight, multiple deliverables, better sensors now, better RGB, all tied into one LiDAR head, all plug and play onto the DJI M400. So that's the really exciting thing. You know, that power we've got on our drone now to collect so much data, so much faster, so much more efficient, with still a very high accuracy for it. So in terms of what I discussed with DJI, I was very fortunate to go to the pre-launch of this a couple of weeks ago. They're really aiming this L3 product at the higher ends of the current LiDAR market. So you might know manufacturers like Regal like that. This is exactly where they're aiming this product into that market. So first of all, we're going to take a look at this improved range. Now, I know a lot of you will be looking going, well, actually, we can only fly 120 meters in the UK, and that's completely true on our standard missions. But where we can gain or take advantage of that longer range is on the if we're working, say, in an environment where we have to be able to get lower. So this example here, we're looking at it from a quarry point of view. You know, if we're taking off at that higher level and we're gaining altitude up to 120 meters, we're not compromising any of our data by flying at that altitude and getting right down to the bottom. In this case, in this mine. So this is an example we've got from a use case I'll touch on later on. So I won't stay too long just an example of the railway there. So as people always say about when it comes to LiDAR is that ability to be able to get through vegetation, and this improvement of these 16 returns is a huge, huge, huge benefit. So this is this example we spoke about when it comes to a higher rate and lower return, and being able to pick up them returns coming back to the sensor. So this kind of thing, a higher rate is lower returns, or if we set it to a lower rate setting, we can start to get them 4, 8, 16 returns if we set it on a particular hertz. So that's really important when we've got maybe a very vegetated environment. We can strip back that vegetation to produce that model. And this is an example of a data set they captured in China, where again, we've got this use case at the end. We can go through in a little bit more detail, but being able to really get through this very, very dense vegetation to get these kinds of quite amazing results from this kind of LiDAR sensor. So this is just this a cross section through this. So for better penetration, it's suggested you work at the 350,000 hertz on the 16 return, rather than just doing the highest rate possible. This will actually be able to greatly improve being able to get through that vegetation for it. So where the use cases are, and this is certainly forestry, cultural relic archaeology, geohazards in environments. So yeah, the possibilities are endless for a LiDAR system like this, and all means this stronger penetration. I've got some really good examples at the end where we've got actual data sets comparisons between the L2, between the L3. So really, really excited to show them results at the end. So you might remember from the L2, there was always two scanning modes. There was the linear and the non-repetitive. So typically we'd always say if you wanted to have that higher end of accuracy, then we would use a linear penetration. And then if we wanted to be able to greatly improve our chances of getting through the foliage, we'd always put it on a non-repetitive flight pattern. But we took a little bit of hit on the accuracy with that. So what DJI have done is they've introduced this new scanning pattern called a star shaped, and it's kind of the best of both worlds. Still increased in terms of our accuracy, but still being able to get a really good chance of getting through this vegetation as well. And this is an example of these scanning modes here. So just that linear, that sort of narrow figure of 8, and also the star-shaped one in the middle, as well as that non-repetitive, which we'd use just if penetrating through vegetation was our main goal there. So this is a nice new update in terms of if we want that best of both worlds. And an example of that we can use is this cross section below, where using this star-shaped one, we're not only getting underneath this vegetation here, but we're also getting some of the information on the elevations as well for that. So improvement on the IMU, so it's got this 200 hertz refresh rate that in terms of the position and the heading accuracy is greatly improved. And this then, when you run it through DJI Terra for the processing, uses the tightly coupled method of producing then highly precise data from our LiDAR sensor. So basically it's an upgrade across the board. It's not just an improved LiDAR sensor, and they've left the same tools inside it. They've increased and updated it across the whole board. So yeah, no preheating at all. L1, we had to always wait for our L1 to preheat. L2, there was still some calibration we had to do. With the new L3, that's reduced even further. So when it comes to doing the flight, like with the L2, there was quite a lot of calibration we had to do outside that survey field. Now with this improvement to that, that's heavily reduced even more so, greatly improving your efficiency when it comes to site data capture. And this is just an example of showing that. So we're not having to go way outside that survey area for it to do the calibration where the drone goes backwards and forth. That's greatly reduced with this new and improved IMU on it. So then to the thing which I was really impressed by is this brand new dual 100 megapixel cameras. So still uses using a micro 4/3 of an inch sensor, and we can still change this if we wish. You know, if we want to be able to do faster shooting in intervals, we can downgrade that to a 25 megapixel image. But also, what the exciting thing to look at is just your GSD levels. When you are flying at about 120 meters, to be able to still achieve a 1.2 centimeter GSD. Now, that's improvement of what, say, the Zenmuse P1 was with a 35mm lens, whereas typically if you're flying at 100 meters, 120 meters, you'd probably get about a 1.25, 1.3 centimeter GSD. This has been improved with the L3. So that kind of, like I mentioned at the start, be able to collect both sets of data, be able to collect a highly accurate, highly detailed ortho, along with collecting high quality LiDAR data as well. Whereas I know some people with the L2 were doing 2 flights to be able to achieve the same results. Now you can do it all in one. And yeah, with this oblique ray, obviously we've got this much wider field of view, which, you know, when we're working in very kind of hilly environments, we can actually capture all the faces of quarries as well for it. So again, big improvements that vastly improves our efficiency as well, as we can see from the graphic as well there. Um, Being able to fly with a less side overlap as well is a huge improvement. So even when it comes to the photogrammetry, when we have to have that minimum 60-degree, 60% side overlap, now we've been able to do it with this oblique ray by reducing that even further. So LiDAR capture tick, photogrammetric capture tick, still at a very, very high efficient rate for it. And that data then can be all put into DJI Terra and processed all in one. There's no need now to have to do a LiDAR process and then a photogrammetric process. It's all done in one step inside DJI Terra. So the only thing just to be note, if you've already got an M400, there is also a new bracket for it. This does come with the L3, which you have to just remove with 4 simple bolts to put your L3 on. This is purely down to the weight. So if you are looking at it from if you've already got, say, the M400 and the P1, you can't use the P1 or the L2 on the new bracket. You have to use it on the old one. But I think with the this use case of being able to use that L3 for everything, then you would just keep the new bracket on and utilize it for all your workflows for it. Typically, as you'd expect with the DJI equipment, it does come with an IP rating of 54, and it's been tested. So even if you are using it in the depths of winter or the heights of summer, it won't affect your operations at all. And as we'd expect, DJI were one of the first, well, they were the first LiDAR manufacturer to be able to put this LiDAR system on this 3-axis gimbal, which makes it really useful when you are doing penetrating through vegetation, or you are trying to do facades with it as well, that we can direct where we want this scan pattern to be able to produce the best results, or find them that data capture where we need the data most. So yeah, L3, as you'd expect, works with this power line follow me function. I'm not sure if any of you guys have tried it. I think it's a really great feature. Really takes that stress out of a pilot being able to capture that data efficiently. We can let the drone do all the work by it focusing on where that line is and following it across. So yeah, this improvement for the power line sector, the L3 is a really, really great choice. From basically what I touched on as well, that we've got a much greater field of view. So we're capturing much more data in a single flight than what we were doing previously. I know some businesses, if they were doing power lines, they found that they had to do almost a flight going and then coming back. Now with the L3, that's certainly limited, and you shouldn't have to do that in most environments. So laser rangefinder has been upgraded up to 900 meters now. Nice little feature for it when you are utilizing this in a LiDAR flight, so you can be able to judge how far away from a certain object. You know, safety is paramount. Certainly, when we're looking at these systems and operating in this power line perspective, we can now get a very highly accurate live distance when it comes to flying in these environments. So just for a bit of peace of mind, we can always do a quick check by facing that LiDAR at that environment and know how far away we are from it. So yeah, these recommendations, not only are DJI going to be able to provide you with the best spec and the best specification in terms of how and what settings you put on, you also get a live update on it. So certainly if you are using things like terrain following, the DJI Pilot 2 will update the best parameters and ask if that's the sort of the settings you want to run with for it. So it's taking that kind of allowing you to be able to put somebody maybe in the field with maybe limited knowledge on lidar, but with some upskilling and some tuition, they'll be able to collect highly accurate, detailed data in the field with the support of the software and the hardware as well in tandem. And now you can also see the display modes from 3 datasets. So like with the L2 and the L1, you've got this live point cloud coming through. You have the live feed from the FPV, and also you have the live feed from the sensor itself. So you've got basically 3 datasets you can interrogate and look at to make sure that you're flying effectively and efficiently, flying safely, and making sure you're collecting good data through the whole process. And also the on-site measurements. If you've used anything like the Matrice 4 in the past, this tool to be able to take direct measurements in the field, that's been now added to the L3 sensor as well, and this will directly connect to Flight Hub 2. If any of you guys have used that as well to be able to interrogate, take cross sections, just be able to get that data quicker. Typically, certainly in construction where time is of the essence, people are always saying, "Well, you've got that measurement for me, you've got them volumetrics for me." To be able to do that in an efficient time, the L3 does allow for that. Or even in time sensitive areas like it lists there, like emergency mapping, disaster relief. You can make them just informed decisions on the ground, fast and efficiently. So kind of just a bit of a roundup there of what the new L3 is and what's included in it. So I'm really excited about this. I think it's a really, really great update. I know before when you see upgrades from manufacturers, you think, well, so what? I think with the L3 now, there's that huge, huge increase to not only what you guys can offer as part of a business, but in terms of data quality, data accuracy as well. So in DJI Pilot, they've improved some of these flight routes. They've given you a lot more autonomy, a lot more kind of input on the flying side of it and the data capture side. I know talking to some of you previously with the L2, you wanted to change things like start and end points. You wanted to reduce. You wanted to stop the drone flying in certain areas. You can all do that now into DJI Pilot as well. So it just gives you a lot more control of how and when you collect that data as well, and with some additional features like the improved automation in the power line inspection as well. So some really nice features into DJI Pilot 2, which I'm sure you will all appreciate. So upgrades to DJI Terra as well. So as you can expect, with the L3, with its improvements in efficiency and improvements in laser, you are going to be collecting a lot of data, lots of data. So that just need to be mindful when you collect that amount of data that you've got that processing power to be able to take that data and process it and get it out the other side as well. And you'll see from some of our use cases how big these data sets can be. But I think with most businesses, if you're going to invest in the technology, invest in the hardware to process that as well. But there have been some additions in terms of the processing side as well. You might remember from DJI, you're a bit restricted in the processing sometimes. There's not too many levers you can pull. With these updates now, they have created some profiles where you can do just very fast processing. You can also do some medium processing, or if you wanted to wait longer, you can get the best possible data set out as well. So a little bit more flexibility when it comes to the data processing of this data set. And there are some minimal configurations just people just need to be aware of. I'm sure if you've used drones before, or you've used LiDAR data sets before, or you have terrestrial laser scanners, you already have this computing capability in-house, but just worth looking at from your point of view that you can achieve these minimal configurations so that you can, when you do purchase that, you can process this data. So yeah, this is just an example of a large data set. So a single flight was around 35 gig. That was 14 gig of raw LiDAR data. collected over 12 flights at 300 meters, so huge data set, a lot of ground covered in that. And this was the results from processing it, turned into a 64 gig point cloud from that. So just be mindful. I'm sure you guys are already very well aware of how to handle large data sets, but just from a software and capability point of view, it's worth just looking at that as well. So the flight trajectory, this is something which is a nice feature. You can just process through high quality data sets. Again, looking back at previous versions of Terra, you're a bit restricted. You kind of just threw everything in and hope that it would come out the other end. You've got that ability now to clip trajectories. So typically from when I used to process LiDAR data, we'd always cut out, say, the turns and stuff. You can do that now in DJI Terra, so you're left with the best possible data set at the other end as well. So I'm sure you guys know DJI Terra is a really good, nice to easy use software. With all these new features which have been added, it's still that same playbook. It's still easy to use. It's still a few clicks to get the desired results out the side. So yeah, more functionality into this return region of interest and clipping. So, standard wise, you could just do a polygon for it. Now, when it comes to DJI Terra, you can pick certain environments. So, like for example, they've selected a DJI Terra, a DJI symbol for it. So that more functionality when it comes to cropping that area. You might have captured a huge site, but maybe time is of the essence. So you just want to process a small part of that data set first, get that out the door, then process the full data set afterwards. You can now do that in the updated version of DJI Terra. So even with these large data sets, you can do something like block processing. So it's not throwing full, let's say for that previous example of like 14 gig of raw data, you're not throwing all that DJI first. You can split that up, process it in much manageable bite-sized pieces so you can process efficiently, basically, and still get the desired results out the other end. This is basically just touched on this, be able to segment your processing areas. So you can basically spec up that block processing size to the kind of spec you've got of your computer. If you get that sort of lower limits, you might want to do smaller blocks to be able to process the data set through. So another really welcome addition to DJI Terra is the GCP and checkpoint functionality. Now, obviously from photogrammetry, I'm sure a lot of you are aware of the being able to coordinate with ground control points. Now, with LiDAR, like with the L2 or the L1, we could just do a gross check. It'll just give us a Z comparison by putting our survey point on the ground, finding its nearest point, and basically giving a difference between that, which was all fine. It gave us a good understanding of good kind of what's been achieved in the field. So with this new one, it will adjust the elevation, not the XYZ. It will just slightly either drop or improve that Z, and that's really important when it comes to achieving them high-end accuracies for it. So this is for me personally a huge improvement. This is why for me I like to see new sensors, new software packages really talking and listening to their customer base. This was a big thing when we always get asked it when it comes to LiDAR. When can I start adding GCPs in? Well, you can now, but just remember, it'll just be that difference when it comes to the Z elevation. And we can still do a mixture of ground control points. We can still do that mixture of checkpoints as well. It just really helps us validate that data set in the process, and to make sure that we get that nice high quality data set at the end. There's some functionality just improved in terms of the accuracy. So we've got an improved optimization when it comes to the consistency of point clouds and utilizing that flight overlap. So things like strip alignments are improved. So really getting the most out of this high-end data set as well for it. The smoothing as well, we're going to try and in some of their algorithms to retain some of them features. Sometimes, certainly from my experience, that smoothing was a little bit too heavy in areas, so they've reprogrammed that so that we can still define or still keep some of them hard features with it. And also, like in DJI Terra, we can calibrate our L3 as well. So None of this sort of sending back the LiDAR sensor to a manufacturer if you suspect there's a fault with it. You can now do that with yourself in the field by doing a LiDAR calibration run and then running it through DJI Terra to give you a updated calibration file. So you will notice on this slide that that's all done through the CF Express card. Previous generations of LiDAR, it's used the micro SD. With the L3, because it collects the sheer amount of data at speed, they've now moved on to a CF card, which is included into the L3 as well. So it's just a note to remember when it comes to the data collection side that it does use an upgraded data storage facility, which the previous versions didn't. So in terms of also in DJI Terra, there's more in terms of the classification. If you used it previously, it'll just do a ground and off ground point. They've put some more algorithms in there. But really, in terms of if you want to do any further more for it, then certainly there's a third party product or the improvements now to DJI Modify. If you've not tried DJI Modify, definitely worth looking at is that next step when it comes to your LiDAR data. So yes, we have got the functionality in Terra for processing, and be able to remove vegetation, etc. But if you want to really, really get the most out of it, exporting that to DJI Modify for further classification is really, really worthwhile to do. So also got things like the point cloud render as well. So as I previously touched on before, this whole workflow in DJI Terra has been streamlined. Before, when was doing RGB data set collection and LiDAR collection, we had to process them individually, which is sometimes quite frustrating if you want to just set the job running and let that run overnight. Now you can process that all in a single batch. So from essentially one data set, a few clicks, one processing project, you can produce your results you'd get from photogrammetry, results you'll get from LiDAR, all in one. And also, when it comes to the processing, it's more efficient. So we're using, even for the photogrammetry data capture, we're using that LiDAR point cloud underneath to improve the efficiency from it. So big improvements when it comes to data processing as well. It's not just on that hardware side. An example of going through on that one. So yeah, we heard about splatting for last few months. I'm sure you've heard the buzzword on social media and from other manufacturers when it comes, but yeah, this has now been added to DJI Terra as well to get them very high-end, visually pleasing results from our data capture. So produce some very, very high renders. If you're doing things like walkthroughs or wanting to show what a facility or a site looks like, then the splatting in DJI Terra is very, very good. Definitely worth having a go at that and seeing if them results fit your needs and wants for that. Yeah, and this is this fusion mapping I touched on previously, just about being able to use the LiDAR data set in tandem with our photogrammetric process as well to really, really speed up results and create these highly detailed, fast processed data sets for it as well. And there's something they've called point cloud fusion for it. So taking data sets independently from two different sensors to produce these kind of results for it as well. And that's all done in DJI Terra automatically with very, very minimal input from yourselves for it. As you'd expect, normal features in DJI Terra, DSM, the contours. I'm sure you guys have played a lot with this already. So here's the important use cases, and I know a lot of people always said, yeah, all very well, you going for a spec sheet with me, but what were people actually getting these in the real world environment? And DJI have been testing this equipment for the past few months with their businesses they work with, their clients. So this is actual real world scenarios where it's been utilized. So the first example I can use is it's 120 kilometers of topographic survey. This was basically required a 3 centimeter DEM. This was a town in China. Whereas in the example that we used when we went to see them at the pre-launch, they showcased this one. This typically was going to take them about 7 days to do via drone and an L2. They managed to complete it in half that time, utilizing the L3 and the M400 and the power cell. So they were charging these batteries on site as well for it. And to again achieve this around 3 centimeters in the digital elevation model and 5 centimeters in the 2D. Now that's a colossal survey to do. But by utilizing the L3 with these additional features on it, they achieved it in a fraction of the time as what it normally would have done with a previous generation of drone and LiDAR sensor. So it was all processed in Terra, split into 5 blocks. It was 12 flights in total, 196 GCPs and checkpoints, and over 120 square kilometers of data capture. Hugely impressive site, hugely impressive data capture, and I'm sure a hugely impressive data set at the end of it. So you might be looking at it and go, well, yeah, that's in China. They've got slightly less lax regulations when it comes to flying drones. But we've got some more real use cases for it. So this was the example we used at the beginning in the open mine. So this was a mining company who had been using previous generations of drones. They'd used the L1, they'd used the L2. This is called the Super Pit. This is the one of the biggest gold mines in the world in Australia. The mine's about 4 kilometers long, 2 kilometers wide, and the whole mouth opening is about 5.5 kilometers squared. And the mining depth is around 650 meters. So the customer have been using DJI drones for daily measurements for many years, and have a professional survey team working on site. Accuracy requirement was better than 10 centimeters. Previously, that took them 3 days to complete, and they've been utilizing before a mixture of Mavic 3 Enterprises and a M400 with an L2. Now, with an M400 and L2, this was taking them around 3 hours to complete. When they took hold and started utilizing it with the new L3, well, their efficiency was just rapidly increased. So this is what they were doing previously with it. It was high risk. They was having to basically take off down at a small plateau down at the side as well. So it was time consuming, not just also in the data capture, but also sending people down into a mine is obviously very, very hazardous. With the increased features, increased range of the L3, they didn't have to do that. So it allowed them to capture this data from the top. So obviously utilizing the longer range for it in a fraction of the time. So they did 2 flights, and this is a good comparison. So they did a 15-minute flight, which is at 550 meters. That was full coverage. And they also then did a second one where it took where was it 600 meters, and that was over 2 flights. And that was taken in 37 minutes. So huge improvements from previous generations of drones. I've always said before, we're never going to have to collect data as fast and efficiently as we can with a drone, even on previous generations. Now we're sort of taking it to that next step, next step in terms of efficiency as well, without that compromise of data. So big improvements when we're looking at it, certainly from a mining environment, with a still highly detailed, highly accurate point cloud at the end. So yeah, these are just some of the results from it when it came to the data processing. So the L3 flight at the 600 meter altitude was 23 gig, took about an hour and a half to process, and then the point cloud at the end was 44 gig. That's a huge area to cover that full open pit mine in that in that time. It's pretty staggering to be able to do that. And this just touched on when it's looking at utilizing it with the GCPs as well, and the results you can get. Similar like with most survey reports, you get all the residual values from it, not only now just as a checkpoint, but also with the GCP input as well. So we'll look at another use case. So yeah, this is going just into a little bit more detail about that L3 and just the success it had for it. I think that what you'll be very surprised at when we look at some of the other use cases is just that point density per meter, depending on what settings you put on. So there's no better example than utilizing it. In this case, was in France on a railway project. So the background for this was to aim to detect the T shape of the rail at the top, to be able to do things like track deformation, the position of the track itself, and measuring like the cant of that as well, and also the high fineness. What could we pick when we've got these sort of high detailed lidar sensors? What sort of detail can we pick from this as well? So again, utilizing the M400, this was just one battery in it with the L3 sensor, and these were the parameters they chose for it. So it was a fixed single flight at 50 meters, the 2 million points a second scanning rate, single single return, 6 meters speed, and we utilized the linear flight scanning pattern. So this very narrow, almost figure of eight, then with a side overlap as well on that. So it's 2 routes. It was up and down, total of 6-minute flight time. So very, very quick to cover around half a kilometre. So this was split actually into 2 flight routes, so one going and one coming back. And the results speak for itself in terms of the analysis side for it. So data quality wise, it was around 8 gig of raw data. That was the point cloud as well as the images to go along with it as well. Processing time DJI Terra was 10 minutes. And in terms of the thickness, that point thickness was less than 15 mil. And this is the impressive bit. So points per square meter on that particular application, flying it like that, was 6,800 points per square meter, which is incredible for that data capture in that amount of time, flown in that kind of fashion. So really, really improvements to that. So you can slowly start to think in your mind, well, actually, the applications this can be used for, maybe there was a reason why you thought the L2 maybe wasn't for you. Was that the point density side of it? Now this meets that criteria of being able to, again, high point density per square meter, capture it fast and efficiently. And in this environment, capturing everything else as well, under vegetation, measuring the lines as well. So yeah, big improvements for that. You can also see on some of these examples here, they want to be able to measure the T-shape at the top, and utilizing these cross sections along the track, they did get these at the top here as well. So really impressive. It's another example in France where they're using it for scanning a dam for it. So for this, it was just more of a test. What can we really achieve with that L3 for it? Can we use it for monitoring? Can we use it for modeling, finding out details of the dam? Is there any deformation in certain areas? So basically, the aim was, can we collect the best possible data set utilizing that L3 for it? So fixed flying height of 50 meters, same kind of parameters which was on before on the rail track. So 2 million points, 2 million hertz, single return, 6 meter speed, and the linear scanning pattern to be able to get them the possible highest accuracy possible, and then with a 60% side overlap for that. So it's split into 2 flights. So you can see there's a single one at the top, as well as some going down to the face of the dam as well. So total length covered was around 800 meters, and that was all captured in just 6 minutes for it. 2 flights, a back and forth flight, and there was just the main adjustment was just on facing that lidar head to 90 degrees to be able to get that face of the dam as well. And then these were the results. So again, there was in terms of the point density, when DJI went through this at their pre-launch, even them guys were shocked at the point density for it from what Global Mapper was reporting. So there's a couple of differences between the two. They basically said we'll go somewhere in the middle for it, but to be able to achieve the less than 10 mil on the point cloud thickness for it, this incredible point density per square meter. So they've got 2 results. Got 6,500, which DJI Terra was reporting, but up to 13,500 when doing the analysis in Global Mapper. Doesn't matter either or, still very impressive results for it as well. So this was achieved with processing DJI Terra, and then they exported that data set into DJI Modify for further analysis. So to clean the data up a little bit, use some of the smoothing, remove some of the noise, which is typically inherent in lidar data captures. And to perform that classification. So, is this man-made material? Is this a building? Is this power lines? All that available in the DJI Modify. So just some further results from it as well, going into a little bit more detail about the dam itself. All these PowerPoints, this webinar will be available afterwards if you want to go through it, and we'll answer any questions at the end. Just a little bit more detail then in terms of the differences between the two. So see, DJI have gone into a lot of detail when it's come to this analysis, and they've tried it in real world solutions, basically so you guys don't have to. You've got all this information equipped, ready to go. So should you make that decision, you know it's been put through in real world environments for it. This was a quite nice one I put in. I think in terms of the data quality when it comes to doing things like staircases, you've got this full profile there of it, and to be able to make a good, well-informed decision of that by taking levels or measurements from a relatively small, quick flight with the L3. So this is a good thing, and I think it's always important to look at how far we've come. What was the previous generation of LiDAR with the L2, and what it is now with the L3? So this was some data sets captured in Italy, and with the main goal is let's do a comparison. What can we achieve with the L3, and where are them improvements when it comes to the L3? So yeah, two M400s, an L3 and L2, and a high spec laptop for it. So the idea was basically to capture all this vineyard area in Italy and see, well, how well was the penetration compared to the L2? How fast can we fly? That kind of stuff. And then again, results is what you'd expect for it. So this was a very, very large area for the comparison. Took over 2 hours to fly. And it was a coverage of 2.1 square kilometers with some checkpoints put along the way to just be able to validate that data. So this is the difference between the two. You can see on the left-hand side, this is where the L3 comes in. Sorry, on the left is the L2, and on the right is the L3. So you can see in them areas a much richer point cloud. In some of these areas where the L2 couldn't get through, the L3 managed it to be able to get underneath that vegetation. If they look at this other cross section area, you can see it's sort of pillars apart in terms of even some environments there was no point cloud or no data captured at all, whereas with the L3 there was that very nice, very clear profile from the top of this valley all the way down to the bottom. So in terms of proving that this increased returns, this increased laser, this smaller spot size is doing exactly what it said, then the proof's in the pudding with that. That shows that the L3 is much better in these environments, whereas maybe the L2 before was slightly lacking. And this was just again another overview of that valley in these areas, again in terms of the point density. So I know sometimes we've said before with the L2, well, some points are better than nothing. It might be in an area where we couldn't get to, something there is better than nothing. The increased point density in these environments, which is pictured, so with the L2 it was getting around 22 points a square meter, and with the L3 was nearly getting triple that at 78 points a square meter. And then in these very dense areas on the right hand side, an extra almost 20 points a square meter. So if vegetation penetration is the thing you're really looking forward to, you really want to utilize LiDAR for, then the L3 has that potential in bucket loads to be able to greatly increase your chances to be able to get through very, very dense undergrowth. So this was kind of like just an overview of it all. This was flown at 300 meters, the 350,000 point rate, 20% side overlap, and this was flown at full speed, 25 meters a second. In one battery, they got around the 28 minutes in this particular environment and covered just shy of five square kilometers on that. So, due to the taking off from the mountaintop at the fixed altitude of 300 meters, in some areas the actual distance from the drone far exceeded 550 meters, resulting in the loss of real-time point cloud in the preview, but that data was still captured through, and then when processed through in DJI Terra was there. So yeah, so as we kind of like been banging on about for the last sort of 45 minutes, the data quality and efficiency, all there when it comes to this comparison. So as mentioned previously, just because the data is not necessarily maybe included in the live feed or in the live preview after you've done a flight, it is still there after it's been processed. So this lidar sensor really producing the results at these very high altitudes, which it mentions in its spec. 500 odd meters to still be able to achieve very high quality results is massively impressive when it comes to this system. So the noise assessment. So we're just going to take a cross section here. So profile width of 5 centimeters, and the point cloud thickness was 1 to 3 centimeters on a hard surface. And the data quality noise assessment with the L3 was 1 to 3 centimeters on the hard surface as well. Just showing these results of these differences between the two, with the improvements on that side. You guys take that in there. So all these results were run through in Global Mapper. I don't know if any of you guys have used that before, but really useful software for validating and interrogating LiDAR data sets. In terms of the accuracy as well, remember, we're flying up very high from top to bottom around that 550 meters. So all these results is what you'd expect within the specification mentioned by DJI for it. And this was finally getting to the end of it now, just in terms of that point cloud density per square meters. So looking at, even when we was flying at 4 meters a second, we're putting on 2000 hertz for it. At that fixed altitude, 110 meters, so still very high up. We're sort of pushing the limits of what we can fly in the UK. You're getting around 2000 points a square meter, which is massively impressive. If I remember rightly from what you'd achieve with the L2 at around 100 to 110 meters of flight, you may get around 200 points a square meter. So huge improvements in the point density. And this is just a nice look at where we can capture that data on the facade side, with that difference between the L2 and the L3. So much richer data sets on them facades, more information, more detail captured. When we talk about this smaller spot point, it's not just about being able to penetrate through vegetation, but being able to pick up them smaller details as well for it. So yeah, very exciting to see this L3 in action, certainly in these kind of more urban environments for the data capture. And if we look at the cross sections for it as well, we can see this come through, even capturing small stuff like the rails you'd have on your vehicle for going on holiday with, to be able to capture that at such a high altitude. Again, massively impressive for it. And also the point thickness as well from there. So hopefully you can see that the upgrades DJI have done for this L3 are not just kind of like you'd get with some manufacturers, like, oh, it's an updated version. This is a huge update, huge updates from the sensor, the IMU, the range, the accuracy. So yeah, a real must-have if you are looking at utilizing LiDAR in the future. So really grateful for you guys joining me today. There is some questions I will go through, but we have got some limited offers for it, where we've basically got bundles available for businesses who want to start using the M400 and L3, where we'll include everything you need in terms of the hardware, but there'll also be setup and guidance from ourselves as well. These will be hands-on sessions at our Leeds office as well. So it's not a case of just buying this product. It's a case there of us actually supporting you with it to make sure that you're a success of it. Make sure that you get the most out of your investment. The worst thing we want is for businesses to buy this sort of stuff and they leave it in a cupboard somewhere because people don't know how to use it or people don't want to fly it. We'll install that confidence into pilots to make sure that they're getting that possible best use of data as well. And if you are thinking about that and you've already got pilots in place and want to bring more on, then we're offering 50% off GVC courses as well, along with a package. But we've only got 20 of these available, and I know they will go quick, but we can do the training as well at our places up in Leeds as well. So you guys, again, can make the most out of this. If you've already got a drone or you've already got some LiDAR, like an L1 or an L2, there is a trading opportunity as well, where you can trade it in and get some money off a brand new package as well. Same deal price for the GVC courses as well. But yeah, please have speak to myself or get in contact with the team about this. My email address is james.pick@copters.com. And if you'd like to give me a call at some point, my number's 07950 523 050. So I'll go through now the questions which have been submitted. So one is from Connor. Let's have a look. So first of all, Simon, yeah, the webinar will be shared with you guys. So yeah, you'll get hopefully linked by the end of the day with the webinar on it. So if you need any further questions or anything answered on that, get in contact afterwards and we can go through it there. Let's have a look at the questions. So someone here, Connor, I was thinking of investing in the M300 and the 400 and the P1, but wondering where the L3 sits alongside it. Can you see somebody having both, using the P1 for photogrammetric and L3 for LiDAR? No. So as I sort of mentioned in terms of the hardware and the software processing as well, the idea is that you will have this one sensor to collect your photogrammetry and your LiDAR data set as well. So the important thing here is utilizing that DJI Fusion. When you are collecting data, you're collecting that LiDAR data, which will sit underneath your photogrammetric processing and be able to get the results you need. So that's the important thing. Data capture in the field, single flight. Processing in DJI Terra, single process with the abundance of deliverables from that as well. I hope that's answered your question okay. Jason, it's been a while. Thanks, James. Looks great. Just to clarify, DJI Terra will remain free for producing the point cloud and the trajectory. So with the L3, you get a year's free of DJI cluster processing. So whereas before DJI cluster was an additional feature, you had to pay for it. That's now been discontinued as a separate package. DJI processing with the cluster comes free of charge as part of the L3, along with care and warranty as well. If you need any further details on that, then please let me know. And I think that's everything for the questions. If anybody else has got any further questions, please let me know. Yeah, thanks for joining me today. And yeah, cheers.